حكينا عن هيدا الفانكشن، رجعنا حكينا عن XOR gate, and we said we have two options. The first option is to find the Y bar expression, draw the pull down device from it, and then build its dual to get the pull up network. And the other option would be to build the pull down network اللي هي نحن حنقول هي A series with B parallel to A bar series with B bar, and then draw from the expression of Y the pull-up network. But when we use the expression of Y as the pull-up network, ساعتها I need to be careful in handling the inputs. بينما if I draw the pull-down and the dual, I keep the inputs the same. Okay, that's the only difference. So إذا جينا عند drawing, and if I want to draw from the pull down network the dual, I will have A in series with B, بس نرجع نعيدها A bar in series with B bar, build pull down, okay, and this will be in parallel and they will connect my output to ground, and then the pull up network will be the dual. So I will have A in parallel with B, and then this in series with كمان A bar in parallel with B bar, and this will connect the output to VDD. هيدي is the pure dual, and if you notice in the pure dual we will maintain إنه إذا هيدي هي الديول لهاي البرانش بدل الانبوتس the same. Okay, so the dual will maintain the same types of inputs applied to the P and to the N. So let us see in the slides how they implemented this. So if you see here in the slide حط لي A bar parallel to B bar, and here I have A bar series to B bar. So he implemented the dual from this. هلا the alternate implementation, and this implements this function. Okay, but it is not a direct mapping. So this is not a direct mapping. We derived it, not the directed dual. We derived it from mapping. We derived it from the dual of the pull-down network. Okay. هلا إذا بدنا نجي نرسم الفانكشن as is، هنرسم البول داون A B A bar B bar. Okay, the same like this one, and then I can alternatively draw the pull-up network. إنه أنا عندي هون A in series with B bar or A bar in series with B، بس بدي يصير آخد الترانزستور as bubbled. Okay, so I can draw here A in series with B bar, and I can draw A bar in series with B. بس بما إنه ال PMOS is يعني إذا جينا حطيناهم، لو أنا عم بستعمل NMOS كنت قلت A in series with B bar and A bar in series with B، or مع A bar in series with B. بما إنه أنا عندي PMOS device, it is inverting, so I have to bubble and invert. bubble هون بنشيل هاي bubble، بنشيل هاي bubble، بنحط لها bar. Okay, so then the block can be drawn as in this form. Okay, يعني بعمل inversion للinput. Okay, and I keep the series and parallel relation the same when I want to use from the Y expression. When I want to use from the Y expression directly in pull-up network. But you don't have to go through this. We can always, يعني what we will take out from the course is that we will always draw pull down and then build the dual to draw the pull-up and no change in input labeling. If we follow this approach. So this is what we are going to follow for the any problem that you get. We will not adopt this one. Okay? We can use it, but we're not going to adopt it. It's much easier for you to do this. Okay? So forget about this. Okay? So, anybody has any questions? Okay. طيب, let us now jump to the next set of slides, which is the sizing. Okay, so إذا هلا نحن عنا network. Okay, here they're showing me how we draw the dual of the pull up from the pull down. I keep the same set of inputs, نفس الشيء، نفس الorder، نفس البارing. بالpull up وبالpull down they are the same, and I just replace parallel with series and series with parallel, and I obtain the dual. And also be careful أنه بنخلي the bracketing the same. يعني the precedence the precedence here remains the same in the when I'm drawing the dual pull-up network. لو قلبت الأور والAND، لو هيدي صارت series وهيدي صارت parallel، okay, I don't flip the precedence. Okay. طب. Let us now, here he's implementing the alternative, the not a dual. شرح لي إنه هو عنده بس بده يشتغلها من الإيكويشن بيقلب الإنبوت، يعني A bar بيقلبها. Okay, but he maintains the same relations that he has here in the equation. So this is A dot B bar or A bar dot B. So what he does is he really flips the inputs. He keeps the relations the same. So here the relations remain the same. Okay, but the inputs are flipped. Okay, إذا بدنا نستعمل ال y expression direct. Okay, so if we want to use it direct. Okay. طب هلا the last part. So here it shows how he drew the block, which we just drew before, and this corresponds to this, and this corresponds to this pull down network. هدول not a dual. Okay. Now he's repeating to me that for the CMOS gate, I have a pull up, I have a pull down. Great, but this is complex network. So I want to make sure if I have a circuit where I have an inverter feeding an AND, which is feeding an OR, and some path coming from somewhere else. If I design my circuit, if the more complex the gate I have, the bigger the delay across it, then I will not be able to optimize in a library fashion my clock design, my design of the frequency. Typically, what they do is they have an ASIC design where they organize things in libraries. They say, well, if my clock is 10 gigahertz, 3 gigahertz, pardon me, then I know that the delay from one latch to another should be, let us say, 0.3 nanosecond or something of that sort. And then I want to insert some logic functionality here. So I want to insert at least, let us say, 5 gates, 5 in the length, depth here. And if I want to insert 5 gates, then the delay of each component should be this much. But if we do not size the gates, then the inverter will be fast and maybe this will be too slow if I use minimum sized devices. So what we do is we size the gates so that they are all uniform, they all have approximately the same delay, such that if I have a CMOS inverter, let us say that this is 2 micron width and this is 1 micron width. And if I have a NAND gate, okay, those two will have the same delay. Now let us see why they may not have the same delay if I put all the transistors the same. And let me say that this is 1 micron and this is 1 micron. Let us look at the pull-down network. When Vn is high, the NMOS device is going to pull down output to ground, the capacitor, right? I can replace the NMOS device by its effective resistance, which is Rn. Here Rn for the inverter. Okay? Hello. If now on this side for the NAND gate, I have inputs A and B are high, and so I have the two transistors, the upper transistors are turned off. Okay, and I will remove them because there will be no path to VDD. And those two transistors are trying to discharge the output capacitor. Okay, then if they have the same size, they have the same resistance, right? So I would remove the first transistor. This will give me a resistor of value Rn, right? Okay, and the second transistor also it's the same size, so it will give me a value Rn. طيب great. هيدا قديش صار resistance that is discharging the how much is the resistance that is discharging the capacitance? It doubled, right? So if I have a stack, then more resistance will be seen on the way to discharge to ground. So I cannot, it will have double delay, and if I have 4 NAND, it will have 4 time delay, and this is a lot. So our objective here is to really size those two transistors, okay, is to size those two transistors such that this is Rn over 2 and this is Rn over 2, so that the total resistance is equal to that of the inverter. طيب and I know that I is K prime W by L, so it's proportional to W. As W increase, the current increase, and therefore the resistance is going to decrease, right? So this means that if W increase or decreases, that R is proportional to 1 over W, or W is proportional to 1 over R. So if I have this relation, and if I find out that I want to size each one of the pull-down transistors of the NAND gate, okay, to have half the resistance, and if I want to have half the resistance, then the transistors of the NAND gate in the pull-down network should have إذا هن inversely proportional قد لازم يكون ال W لإلهم. إذا resistor راح بالنص وهي inversely proportional it should be 2W يعني بدها تكون 2 micro. Okay, so if this is Rn عفوا if this is Rn, okay, and I want the sum of them to be Rn يعني بدي كل واحد من الترانزستورز يعطيني Rn over 2, okay, then I want their width, okay, إذا هيدا هو عنده 1 micron هيدول يكونوا هن كل واحد منهم twice لأنه إذا resistance divided by half then the width should be multiplied. R is proportional to 1 over W. So this is very important. حنشوفها هلأ more clearly on the other slides. Okay? حدا عنده سؤال? Anybody has any question? So based on this, we are going to build some rules that we will navigate through the slides. Okay? So لكينا نحنا when we do transistor sizing we try to search or look for the worst case resistance path. يعني أنا I may have a gate, let us say, that has for example CMOS in parallel, and then let me just draw a function. 1 second. So I may have a gate where the pull down network looks like this. It has 2 transistors like this. So this is A, B, C. So for this function, my Y bar, and this is the output. So I know that Y bar is equal to A times B or C. Okay, and then the pull-up network is going to be A, okay, or B, and then with C. Okay, so if I have given this gate, if I want to look for the worst case resistance along the path to ground, I need to find what is the longest path between the output and the ground. Okay, and this should be have the same delay as the inverter. ليش؟ لأنه أنا when I am operating, when I am pulling down the output, I can pull it either through this path or through another path, which is this one. يعني C or A and B. And these are, of course, I can have all of them. If all of them are on, pulling down, this is good. The more the merrier. Okay, if all of them are pulling down, I will have a smaller delay. But what I care for is that as I am pulling down through one route, يعني يا green يا yellow, I want to size them such that this route, the green or the yellow, have the same resistance as that of the inverter. Okay, so the worst case resistance, يعني every single path from out to ground should have equal delay or resistance to that of the CMOS inverter. But هلا, typically we start by identifying the longest one. And then if there are dependencies, we move down to the shortest ones and we continue sizing, and we will see an example. Here the two passes are independent. يعني I can size AB alone and then size C with them. Okay. مثلا بالpull up, if we look at the pull up pass to VDD, I have to have either CA or CB. One of these two passes, if it is on, then I will connect the output to VDD. Okay. Anybody has any questions? Okay. So here we have the transistor sizing. Okay, now let's see what it is going to tell me. The second point that it is telling me is that the resistance of the MOSFET is inversely proportional to W by L. يعني R is proportional. Typically, L is fixed. Typically, the length for the device remains constant. So it's proportional to 1 over W, or we can say it's proportional to 1 over W by L. For a given technology, L is always constant. So it's mainly the issue is with sizing W. We always care about sizing W. Okay, so if I want R to be double, I need W to be half, and if I want R to be half, I then need W to be I need W to be twice. Okay, يعني if I want R over 2, I will need 2 times W. Okay, and vice versa. Okay, great. So R is inversely proportional to W. For a path of N transistors in series, if I have N transistors in series, مثل NAND example, إذا عندي أنا هلا 1 2 3 لعند N مثلا 4 and I want them all to be equivalent to the inverter case where in the inverter I had some W, okay, which really if this is out here, okay, which really translated to a resistor Rn بين الأوت والground. Then if this Rn transistor, I really need this to be Rn over big N. بهالكيس هي 4 وهيدا بدي إياه يكون Rn over 4 وهيدا بدي إياه يكون Rn over 4 and the same here. So that the total resistance from here to here is Rn and therefore the inverter sizes should be times 4. Okay, therefore the chain, here I have 4 of them, therefore the chain should be size times 4 يعني هيدي output للpull down network and here I should have this 4W 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 to match the worst case delay of the inverter whose pull down was W. طبعا هو عنده pull up هون كمان بس احنا هلا ما عم نحكي عنها، هلا عم نحكي عن pull down capability. Okay, so هيدي في pull up network but we're not worried about it, we're just worried about up to the output node. هو مكفي على pull up لإله. Okay, so we're worried about this stuff. Anybody has any question? Okay. Great. Let us now clear here and let us go down. Here we have the N input NAND gate. We have the pull-up network has parallel PMOSes and the pull-down network has series PMOSes. Let us try to draw the N input NAND gate. For example, the 3-input NAND gate. Okay, so if I have the 3-input NAND gate, it's going to look like Y equals ABC bar. So Y bar equals ABC, and it will have 3 in series A, B, C, and then it will have 3 PMOSes in parallel. Okay, so this is A, B, C, and this is VDD. Okay, this is VDD, and this is the output. So if I want to see what is the worst case path, يعني لما عندي one route down, I only have one, and it is this series. So أنا if I'm trying to size it to be equivalent to the CMOS inverter where the pull-up is sized P and the pull-down is sized N. هيدا اللي N لإله وهيدا الpull-down is sized N. Okay, if this is size N, then if I want, let me just change the color of the network here بس حتى ما يكون مثل P. Okay, so if I want to size these to have the same effective resistance, هعدهم 1, 2, 3, and I will say I have to use a 3N, 3N, 3N. So the size of each N must لأنهن in series will be N times N. For the N input here, N is equal to big N equals to 3 here. Okay, ليش؟ لأنه هيدي حتعطيني R over 3 plus R over 3 plus R over 3. Okay, طيب هيدي تطلع R وهيدي عندها R, so I am fine. Okay, هلا from the pull-up perspective, the worst case delay is when one of these routes is pulling the output to VDD, is charging the output to VDD. So I have only one transistor, and here I have only one transistor. So if I size this as P or this as P or this as P, then each single path from output to VDD will have the same resistance as from this to VDD. So since the PMOSs are all in parallel, the W by L will be set to have the same ratio P, or the W will have the same ratio and same value as the W of the inverter, لأنه L is common, is equal in all cases. Okay. طب anybody has any questions?
Professor إنه it's the same يعني إنه لما يكون عندنا مثلا a NOR gate أو شيء إنه بس بيصير عندنا ال worst case مثلا بال PMOS كمان بيصير N times P.
صح. So we're going to talk about this and then later talk about an example of a slightly more complex gate. So لكن as you said Karim, for the N input NOR لأن النور شكله عندي parallel بالNMOS يعني عندي مثلا let's take NOR 2 and let me draw it a little higher. So for the NOR gate, because I will have the P in series, okay, and then I will have the N are in parallel, okay, then I will size each one of these as N, and then for the series path, since I will pass through two of them, this will be 2P and this will be 2P. Okay, yani for the NOR gate, the size of each PMOS is equal to N times P for the N input NOR, and the size of each NMOS is equal to N, where we said that clearly that for the inverter, I have the P sized P and the N sized N. عم نحكي هون in relation to the CMOS inverter where this is N and this is P. يعني this number is what is being used in these equations here. Okay, so this is P, and this is the N times P, and this is the N, and this is the N times. Okay, so هيدي ال N هون N times N هون بتلا. Okay, طب هلا we're gonna see a couple of more examples beyond this examples. Let's see. طب this is a 4 input NAND. Okay, هيدا ال pull down path فيه 4 stack of 4, so it will be 4N, 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 4N. And here the path is 1, so it's going to be P, 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 P. Okay, let's take another simple example. This is the 4 input NOR gate. This is 4P, and this is 1, so this is N, N, N. Okay, great. Let us now take this gate example. Okay, so this is A and B or C and D. If we want to draw this gate, and we'll look at the slides later, this gate will be really Y bar equals A series, B parallel, C series with D. Okay, and we keep the precedence here. We make sure we maintain it. So the smallest bracket is C in series with D. Okay, and this R in parallel with B. And then all of these are in series with A. هيدي the pull down block. Okay, if I want to draw now the pull up block, it's going to be dual. So it will be A parallel to B series with, keep the precedence, C parallel to D. Okay, so I will start with a C parallel to D. Okay, and this will be in series with B, and all of these will be in parallel to A. So I always start from the innermost block, بلش بالC parallel to D, then I make it in series with B, then I make them in parallel to A, and this will be between VDD and ground and the output. Okay, so let us now look at the circuit, how it is drawn for us. Here they put A on top, it is fine, it's the same. Now this is the output line. I want to find the worst case path for the pull down. So the worst case is when one route is on, I start with the longest one. This is the longest single route, A, C, D. Okay, it is 3. So I'm going to size this as 3N, 3N, 3N. Okay, great. Now what do I do? The second path is this path. How do I size B? Okay, I know that either by symmetry, I look at this compared to those two and I say, oh, it should be half the width, or I did you guess it later, or I simply just start writing RA plus RB has to be equal to Rn, but R is inversely proportional to W. This means that 1 over WA plus 1 over WB is equal to 1 over N, right? I know what's WA, it's 1 over 3N plus 1 over WB equals 1 over N. So I will end up finding that WB has to be equal to 1.5N. Okay? This is the straightforward derivation way. Okay? So let us now look how else we could have done it if I had sized this as 3N, 3N, 3N. كنت بدي اجي اقول انه هيدي هي R over 3. This means that this needs to be 2R over 3 if I'm following this path, and therefore the W would be 3 over 2 times N. يعني you can either use the 1 over W or use the resistance. 1 over W is also fine, and invert يعني ratio. Okay? Okay, so let us see how the slides calculate this. So ACD means all of them have to be 3. Okay, and then it says NB is in series with NA, so I have 1 over NB plus 1 over 3N is equal to 1 over N, and we find that NB is equal, WB and equal 1.5N, or W by LB. Okay, إذا N كانت W by L. Anybody has any question? So let us now look at the pull-up network. The pull-up network has 3 individual paths. This one, its length is 2. This is the longest path. So here I will have 2P, and this is 2P. This second path, by symmetry, مبين هيدا parallel لهيدا. So by symmetry, it has to be 2P. And then this path is independent. It's a standalone. So in the worst case, if A alone is pulling, then this has to be sized equal to P. Okay? Okay. Let us see what the slides say. It says BC or BD is the longest path. And so I'm going to start with their sizes since there's symmetry S to P. And then PA, I'm going to size it equal to 1 times P. Okay? That would be great. Anybody has any questions so far? Okay. هات لناخد, this seems to be the dual problem. هلا عطاني y equal A or B into C or D. So y bar is equal to A or B into C or D. So it's equal to A parallel to B series with C parallel to D. And let us start with the innermost block. Okay, so if I start with this innermost block, then I am going to draw really followed, يعني إذا بدنا نلحق ال precedence, just 1 second. يلا خليني erase this. So if I want to follow now the precedence, the order of the blocks that I am going to execute would be the first block, then the AND function, then the whole thing. Okay, so إذا نلحق ال precedence هون لو كنت عم بعمل multiply و add, كنت I need to resolve this, then I need to resolve the bigger one. So حنبلش لكينا هلا نرسم C parallel لل D Okay, so this is C in parallel to D. It will be in series with B. Okay, 1, 2, 3, and then this will be all in parallel to A. So this is our pull down network. Okay, and then we will have for the pull up the dual, يعني we're going to write A, B, and then C parallel D. هلا هون بدنا ننتبه للبريسيدنس كيف مشي لأنه we maintain it. Okay, so I'm going to inject here the brackets إنه هيدي this was the second block. This was the second block that I drew, and this is the second block that I drew. Now I will sorry هيدي هلا بعبي البارallel بتصير series والseries بتصير parallel. يعني here the parallel will become series, this will become parallel, and this will become series. Okay, so here I will have C in series with D. I will start with the innermost block. Is it clear or should I repeat it? Okay, let me just repeat it for the sake of the recording. So هلا برجعني طيب. So أول شيء ببلش ب C in series with the D, and then these are in parallel with B, and all of these are in series with A, and this will be connected to the common output, and will connect this output to VDD when on. Okay, فإذا أنا بلشت بالسي سيريز مع دي، كفيت على البي parallel لهيدي الquantity, and then A is in series with them. So the precedence is 1, 2, 3. Okay, so let me then rewrite the expression بس حتى انتوا تكونوا أكيدين إنه كتبنا الإكسبريشن مظبوط. ال y bar we always start with y bar لل pull down network equal to A or B into C or D. هو عطاني هون brackets بس أنا I am going to insert the precedence, and this will happen before this. And therefore when I write y bar it is simple. Okay, so this is A and B, C or D. هذه عفوا I have then another bracket for C or D. Okay, the OR becomes a parallel, the dot becomes a series, and the OR becomes a parallel. But I already here what I did is I kept the same, I have the precedence from the logic function. Okay, so this is to build the pull down network. I'm going to start therefore with the innermost block, followed by the second one, and then followed by the whole expression. When I want to draw the pull up network, okay, when I want to draw the pull up network, I am going to write A, and then I have this bracket, B, and then I have another bracket for C and D. And now what I change is I just change the parallel becomes series, the series becomes parallel, and the parallel becomes series. Sometimes I want to see it from the drawing itself. You will start with this block, then this block, then this block. Is this clear? Anybody has any question? طيب, okay. طيب, let us see now how we do it. يعني نحن فعليا للpull up we're going to take the same expression بس حنحول هاي ل series parallel series وحنمشي بنفس ال precedence. Okay, so let me now clear this and let us see what the circuit looks like. So this is how the circuit looks like. So I have B in series with C or D, and then I have in parallel with A in the pull down. Okay, so again here I will have two options. I start with them, so this has to be 2n, 2n, this will be 2n, and this will be 1n, and it's a path alone. Okay, for the pull-up network, we will look for the longest path, and the longest path will be this one. هلا نحكي على W by L شو هن, so I will have 3p, 3p, 3p. For this path here, I will have 1 over 3p plus 1 over b is equal to 1 over p. So this tells me that this has to be 3p over 2. Okay. Now, he's telling me that for the CMOS inverter, N is the W by L ratio, which is 0.375 over 0.25, هيدي L. Okay, this is W over L, and this is the L here, and this is the W here. So what he does is, if something has to be size 2N, automatically I say 2 times 0.375 على 0.25. So this is going to be 0.75 على 0.25 لأن نحن ال L ما بنغيرها, we do not change it. I just act on the W. So هيدا هو 0.75 على 0.25, 0.75 على 0.25, this is the same. And then this is N, so it remains the same. Okay. In a similar fashion, هون لازم يصيروا 3p, so this will become, if this is a 3p, 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 this has to become 3 times 1.25 على 0.25, which is equal to 3.75 على 0.25, اللي هو number that you see here. You keep L the same, okay, and you multiply the width by the factor that you want here. وهيدي للبي حتكون 1.5 ضرب 1.25 على 0.25 لأن we size it as 1.5. Okay, if I take this path. Clear? Anybody has any questions? طيب, okay, great. طيب, so, yes, Tufik.
In practice, are such CMOS transistors used, يعني? Or just they produce NAND gates and they build them? And do these have practical uses?
You mean do we use complex gates? Yes, we have are called those gates. The ones that are, this is for custom design. Custom design لما كانوا يجوا يحاولوا يعملوا البروسيسور very efficient, very fast for a specific module where the current technology is not allowing me to meet the clock frequency. So designers leave libraries and they start to build custom functions. Okay. هلا, in practice, the libraries have the NOR, NAND, inverters, and they also have what we call AND or invert and OR and invert. What AND or inverts means is A, B, or C, D, or E, F, for example, bar. This is starting with the AND and ORing the ANDed expressions. Will OR and invert بيكون مثلا A or B into C or D bar. لأنه هو common functions that we typically face, and not always we want to implement everything using هلا. NAND والinverter are sufficient, but they build some additional functions that can help sometimes in reducing the area. يعني احنا في عنا delay وفي عنا area as constraint. Okay. Okay. طيب, هلا, if nobody has any questions, this concludes the lectures. Monday we will have SQ12, which, as I told you, is optional, but let me try, I will try to correct for you tonight. I posted SQ11. I will try to correct SQ10 لأنه it seemed that يعني you did worse on it, at least from the model correction. But if I go through the slides, through your solution sheets, scratch, maybe it will be otherwise. So I will try to correct 10 today and 9 tomorrow. If you have bandwidth, go over the average current method and the resistor-based inverter. if you don't have bandwidth, I'm trying to squeeze in the correction for you as fast as I can without really penalizing you. Okay, I want to make sure I go through your sheets. I also want, what I might do on Monday, the first half an hour, I might go over the worst, the common mistakes, at least in the last 3 short quizzes. لأنه many of you were confusing using dB in the gain equation بتاعت AF equal A over 1 plus A beta. So these are little things that you should not do for the sake of the final exam. So I might correct the short quizzes and then give you maybe a little recording regards the common mistake, at least in the last 3 ones on Monday. Okay. طيب, thank you all. Hopefully talk to you soon or on Monday.